Hello, guys. Welcome to part 2 of our July Q&A. My name is Perry. I am the CTO at Argo Blockchain. Our first question here is from Thanasis at Sutos Thanasis. Is it possible to overclock ASICs? And if so, what are the risks and advantages when doing that? Great question. It's very possible to overclock ASICs. In fact, when we use our own custom tuning software, that's part of the things that we do when they're out of warranty. Basically, the risk is lack of cooling. So when you increase the frequency to keep the chip stable, you have to increase the voltage. The higher quality of the chip, the less voltage it requires. Obviously, with more voltage, you create more heat. So if you don't have adequate cooling, then there's a risk of damaging the chip. The other thing that can get damaged is the power supply. If it's being asked to put out more than it's capable of, or you're writing it right at the very limit. The next question is from Sausage Dog 19. Do we have enough hash power to perform a 51% network attack on any mineable crypto? Do you see this potentially happening in the future with the centralization of miners from China? So no, we don't have enough hash rate to perform a 51% network attack on any mineable crypto. And do I see this potentially happening in the future? So the one thing I'll say is that the hash rate drop that we saw when the Chinese miners went offline was over 60-70% of the hash rate of the network at one point. And the fact that that's leaving and it's going all over the rest of the world, I think is a great thing. It makes it far more decentralized, and it makes the network far more resistant to a 51% attack. The next question here is from BTC Bull 47. Hi, Perry. What's Argo Blockchain's pitch strategy for the month of July? One stop, two stop. We'll be switching to soft so we can catch up with the competition. Special tuning, aerodynamic adjustments, and mods on the way. So for those of you who don't know, I am a huge F1 fan. And I believe the F1 season will be taking a break in August. And that's when a lot of these adjustments, they come in, they see how the season goes, and whether it's aerodynamics or suspension, even engine strategy. So I believe what Mr. Bull here is asking is, what will be Argo's, let's say, mid-pitch strategy? Well, the one thing I can say is we're not looking at just this one race. We've got our strategy in place, I think, that we've been using since day one. And I think it's a great strategy from where we purchase machines, the way we run the machines. And the next evolution of that is Texas and Immersion. And I know everyone wants to know everything right away. But Q1 of next year, and hopefully before then, we'll be able to share more information. But we definitely have a couple of different mods, if not a complete rehaul on some of the systems in terms of cooling. We're going from air to immersion, which we think will be really, really beneficial in terms of, hardware failure rates, machine performance, efficiency. So, yeah, I would say that's Argo strategy. Now, if that's a one-stop or a two-stop, I will let you decide, Mr. Bull. So the next question here is from Captain Nothing at Captain Nothing 3. Mr. Hothi, very formal. Please talk us through exactly what you're doing at the Texas facility and how each aspect of what you're doing creates a competitive edge. Please be as specific as possible. I know you're in the bakery baking. Share your baked goods with us. Thank you. Well, I do love baked goods, Mr. Captain Nothing. In terms of every aspect and how it creates a competitive edge. So when looking at the immersion system, we looked at stuff off the shelf, what was out there. But before doing that, we kind of said, I said, what are my requirements for the immersion system before seeing what was out there? And is there anything that meets those? And so one of the things is it's not designed in a silo. When we're designing this facility, we've got the electrical system, and each component, there is a, let's say, sweet spot, for lack of a better term, on the size of transformer you want to use, on the size of the panel. The dry cooler that's going to be outside the building and the pods that are going to be inside. How do you prevent fluid contamination? even something as simple as the number of pumps you use. The one thing we realized is we don't want downtime. And so is it better to spend a little more in advance? So as an example of that would be the pumping system, where we would have an N+1 redundancy, where we can have two pumps, VFD pumps, that are running at 50%. So that's more efficient than running one at 100. But if one were to fail, the other one can easily pick up the slack, go up to 100 until the repair is made. So that way there's very little downtime. Designing a system like this, we're not just designing it for now, but also keeping in mind that if there's maintenance, if there's normal, wear and tear, how do we make it so the machines are, affected the least? Mining uptime is established, but at the same time, we can do the maintenance, the repairs that we need to. So whether it's something as putting in check valves or isolation valves, so we can isolate the fluid, we can make sure the containers the pods are sealed, so there's no dust egress, right down to even the small rubber grommets where the wires pass through. Every little thing was done from scratch and thought through. And, before we even build something, we run it through multiple design phases using software, CFD. And so we don't, waste a lot of time and raw material when we can do it digitally. The next question here is from Kev Wed at Wedgie741. Hi, Perry Hothi. Apart from the reduction in noise by moving to immersion cooling at the Texas facility, will there be a reduction in running costs by using pumps instead of fans? And also, are we using off-the-shelf dielectric fluid, or have you formulated your own? Many thanks. So yes, this is a great question. So the first thing is, when we move to immersion, there are, I'll use an S19 as an example, 4 fans that are 200 CFM each, 2 on the front, 2 in the back. So those come off. And that's where you see your first savings. In air, you've got walls and walls of fans for the intake side and the exhaust side. And those are gone and replaced by pumps. And so is that trade-off equivalent? No, the pumps use far less electricity. The pumps are VFD, so they're not constantly running at the high speed, variable frequency drive. So just what you need. But the other thing is the machines themselves, including the power supply, is running much cooler. And when you run a power supply much cooler, it runs far more efficient. So if you have they have the bronze rated, gold, platinum, those are usually not rated. When they give those numbers, you can see them at a certain percentage of load. As they go up and get closer to 100% load, those ratings come further back in terms of efficiency. So keeping them cool helps in terms of efficiency, the machines and the power supplies. So the next question is from Chris at C Now. What are the biggest advantages with the new Epic machines compared with the current machines that Argo is using? Well, I would say the biggest advantage is when you work side by side with the manufacturer and you're designing for a certain spec, it's, there's no trade-offs. I can ask for something a certain way and, they'll fire back and say, well, why do you want it this way? And we'll go back and forth because our facility will be different than a lot of other places. And so if we can get something tailored for us, that increases efficiency as well. The other thing is the processes of working with a manufacturer and a partner like Epic is it's not just now, but also going forward, what we learn together in the design and manufacturing process and running these machines can be applied later down the road to other projects as well. Well, guys, that was extremely fun. I thank you for all who asked questions. I thoroughly enjoyed it. And I look forward to the next Q&A. And hopefully by then, we'll be able to share some more stuff about Texas with you guys. Thank you.